Hi, welcome to Topic 1, Lesson 7. Today we're going to talk about the zero exponent property. And the zero exponent is pretty straightforward. Any number raised to the zero power equals 1. And there are several different ways that we can explain this. The first one is to look just at a pattern in a table. Here we have a table, and we start out with 3 to the fourth power equals 81, 3 to the third power equals 27, 3 to the second power equals 9, 3 to the first power equals 3. And if you look at the pattern, each time we go 81 divided by 3 is 27, 27 divided by 3 is 9, 9 divided by 3 is 3. And this next pattern, 3 divided by 3 equals 1. So that's one way to look at it. Another way to look at it is to remind ourselves about the division property, where you take two numbers of the base, same base, and divide, and you subtract the exponents. So in this case, what they've done is they've taken 3 to the third power divided by 3 to the third power, which is the same as 3 to the 3 minus 3, or 3 to the 0 power. So there you have a number 3 raised to the 0 power. And at the same time, 3 to the third power is the same as 3 times 3 times 3. And it's divided by 3 to the third power, 3 times 3 times 3. And if you cancel, 3 divided by 3 is 1, 3 divided by 3 is 1, 3 divided by 3 is 1, and 1 times 1 times 1 equals 1. So again, the zero exponent property says any number raised to the 0 power, so any number x raised to the 0 power equals 1. And there's a little bit of a glitch that we need to talk about here. When we do exponents, if we have a negative, so for instance, if we have negative 4, and we have parentheses around the whole thing, negative 4, and raise that to the 0 power, that equals 1, because negative 4, the whole number, is raised to the 0 power. If, however, we have negative 4 with no parentheses to the 0 power, then order of operations, remember, you do exponents first. Well, 4 to the 0 power is 1, and then you do the opposite of that, so it's negative 1. It's almost as if there's an invisible 0 minus 4 to the 0 power, or 0 minus 1 equals negative 1. So that's where that comes from. So that is the zero exponent property. There's a little bit more that we need to look at here. So example 2, this is on page 47. Okay, this is the negative exponent property that we're going to talk about now. So we have 4 to the third power divided by 4 to the fifth power. And if you remember the rules, okay, that should be 4 to the third divided by 4 to the fifth should be 4 to the 3 minus 5, which is equal to 4 to the negative 2 power. That's just based on the division property that we did the other day. Okay, and then what they're showing you here is if you have 3 4s multiplied together, and here you have 5 4s multiplied together, 4 divided by 4 is 1, 4 divided by 4 is 1, 4 divided by 4 is 1. So in the numerator, we have 1 times 1 times 1 is 1. In the denominator, you have 4 times 1 times 1 times 1 times 4 is 16. And so this 4 to the negative 2 power is the same as 1 over 4 squared, or 1 over 16. And I'm going to do that a little bit differently and show it to you again. You take any number and raise it to a negative exponent. That is the same as taking that same base, moving it to the denominator, and giving it the positive exponent. Also, if you happen to have 1 over 2 to the negative fourth power, now you have a negative exponent in the denominator. That is the same as moving the base up to the numerator, and the exponent becomes positive, and that's over 1. But of course, we don't have to write that. So if you have a negative exponent, the whole thing, if it starts out in the numerator, moves down to the denominator and becomes positive. The exponent becomes positive. If it's in the denominator, it moves up to the numerator and the exponent becomes positive. So that's the negative exponent property. And then one more example here. This is just what you do with expressions with negative exponents. And might be a little bit tricky to see. So it says, write the expression 1 over 7 to the negative 3 power with a positive exponent. Well, we've actually already talked about this one. 1 over 7 to the negative 3. Now, what they're showing you in the example in the book is they're taking this part of that problem and doing what they just showed you up above. And then they're doing the flip and multiply that you learned. But I've already shown you that this is the same as move the whole thing up to the numerator. The base stays the same. The exponent becomes positive, and it's over 1, but you don't have to write over 1. You don't even have to write that. Right there's your answer. So that is the negative exponent property and the zero exponent property. And stay tuned for more tomorrow.